So, I mentioned this earlier, but this is a dichotomy that taken together is 100% correct. Either the deck is or isn't fair. When I say fair, what do I mean? When I say fair, what do I mean?
26 black cards, 26 red cards.
Love it. That's what we're calling that a fair deck. 26, half red, half black, 26 black, 26 red. So you're gonna find fair as 26 and 26, or it's not 26 and 26. Is anybody sitting there thinking maybe it's more like 25, 27? Or 24, 28? Anybody thinking like that? Anybody getting that precise, like with what it's actually arranged at? How many of you think it's 0, 52? Oh, okay, we're still thinking. We're still waking up too. It's a lot of questions all at once. But here's the deal. That's one of those two things is true. We never get to know what, but one of them is true. But that case, like, oh my God, this sucks. But that's the way statistics is. When you make a drug, or if you have a massage therapy that uses hot water versus a chemical, and you test a sample of subjects, you don't know for sure if your treatment is actually working, even if they show favorable results. Because it could be that it's not working and they just perform favorably for whatever reason. So you never know with 100% certainty. Just like with Brandon in the 444, right? I mean, I don't know what's going on inside your head. It's like, what? Remember Max and his Crocs from 243? I can't see inside that beautiful blonde head. So I don't know what's going on. But I know that if he got it right 1 time out of 10, he's most likely not guessing. That's the thing. I don't know for maybe he is guessing. It just sucks at guessing. It's possible. But I can't see inside his head, just like I can't see inside a population. So this is unfortunate. But you, as a researcher, have to do one of two things. You have to either say the deck isn't fair, or say the deck is fair. You see there's a little 2x2 table here? This should be reminiscent of your last project in 243. False positive, false negative, true positive, true negative. This is exactly that table, just kind of rewritten for inferential stat versus descriptive stat. So I think, I could be wrong, but I'm thinking most of you are leaning this way. Some of you might be leaning this way. The deck is fair, and that's Max. I love that, by the way. Thank you. The deck is fair. We just got an outlier data. So you wouldn't have run after that kid. You wouldn't have chased. But maybe you would have chased him down. Maybe you would have chased him down. But when he said, "I never run that stop sign," you'd be like, "Oh, that's me." You would have walked away, and not just pounded him like I did. The poor kid backing into looking for the door handle and trying to get into his house before old man rolled exploded on him. He would have liked you much better as a neighbor. He moved out shortly thereafter. So here's the thing. There are 4 results. You say the deck isn't fair when the deck is fair. You say the deck isn't fair when the deck isn't fair. You say the deck is fair when it is, and you say it is fair when it isn't. All 4 of those things have a consequence, okay? If you say the deck isn't fair, but it actually is, that's called a false positive. Think about, let that wash over you. Let that wash over you. Why that is a false positive. Now explain to me in your own words, or anybody else's words, why that would be a false positive. Why would saying the deck isn't fair when it actually is be a false positive? You can also draw a connection to something else if you want. Well, it's false. Good. The false part is because you're wrong. That's good. That's good. The false part is because you're wrong. You said the opposite of what is actually true. And you got to remember, if I may take a small tangent here, Max, you're not going to actually know you're wrong because you'd actually have to know the deck were fair, which you'll never know as a researcher. But that doesn't mean you can't be wrong and not know that you're being wrong. So it's false because you said the wrong thing. Why is it a positive test? If you say the deck isn't fair when it actually is, please, Taylor.
Because it is fair.
Because fair would just be like everything's normal. When you take a test for a disease or for drug presence in your body, a negative test result means nothing's out of the ordinary. It means you don't have the disease. The drug is not in your body in a perceptible amount, or the disease is not in your body in a perceptible amount. A positive test result implies something is off of what it should be. So when you get it, when I pull a deck of cards out, how many of you assumed when I pulled that deck of cards out of my pocket yesterday that it was rigged? Nobody assumes that, right? When you go to watch an NFL game and they pull the big shiny coin out to flip it, do you jump up and go, "Check it for 2 tails"? Nobody does that, right? You assume it's fair. When you go to Vegas, you don't assume they're trying to rob you. The mathematics robs you just fine by itself. They don't have to try, right? So that's the idea. You assume everything's fine. A positive test result means something's not fine. So a falsely positive test result means you said something was off, but it actually wasn't. Thank you, Taylor. Thank you, Max. Perfect, perfect, perfect. Okay, so that's that top. I'm going to plant a seed for later. That's called a type 1 error in statistics. We'll come back to it. Don't memorize that now. We'll come back to that. Okay? All right. If you say the deck is fair and the deck actually is fair, then you did a good thing. You did a good thing. You know what that would be called? You said it's fair and it actually is? So that last one was a false positive, right? False and positive. False because we were wrong. Positive because we said something changed when it actually happened. So we said it wasn't fair, but it actually was fair.
Is it a positive? No.
It'd be it'd be a true negative. You're saying the right thing. It's a true negative because we were correct, which means it was true, and we said it was fair, which means nothing's wrong. It's like testing negatively for a disease that you don't have. You don't have it. You tested negative, and thank God it was right. It's a false negative. So it's a false negative. You're not saying anything changed, and it actually didn't. That's a false negative. It doesn't have a fancy number or name or anything like that. It's just a false negative. Okay, let's keep going. Keep going. If you say the deck isn't fair, and indeed it's not fair, you know what that would be? You're right. I mean, right. Yes. Smiley face. So if you're right, is it true or false?
True.
It's true. And you said it wasn't fair, which makes it a true positive. You flagged it as being different. Joy, ask me that question right now. Okay, I'm sorry, I misread your eyes. Processing, gonna like processing, that makes me happy. It's a true positive because you flagged it as something's up, and it actually was. That would be a true positive. That's like taking like for example, my thyroid levels were exceptionally high the first time I got them tested. And the first thing my doctor wanted to do was put me on thyroid medicine. I'm like, whoa, time out. It might be a false positive. Let's wait and see. And then I tested 3 more times, and they were always higher than they should have been. And I said, okay, now it's too hard for me to believe that they're all false positives. Now I believe they are true positives because I've got so many of them. Does that kind of make sense? So that's the idea and again, I could be wrong. Maybe I did something else during the blood testing process that triggered those. That's when you look at other data and try to make a more informed conclusion. But seeing 4 of them in a row that are all positives makes it a little hard to believe if I'm doing the tests correctly that something isn't up. Good. And last but not least down here, the other oops. Everything's fine. Everything's fine. Everything's fine. But you're wrong. That's a false negative. That's a false negative. Type 2 error in statistics. We'll come into that. That's more like week 5, week 6 stuff. We'll really get into that and start really whittling away at those corners. So those are the 4 things that can happen when you run a statistical test. One of those will apply to you with how you draw your conclusion with a statistical interpretation. You're either going to be right or you're going to be wrong, and there's 2 ways to be right and 2 ways to be wrong. Our job in this class is to teach you how to maximize that while minimizing that. Can you ever make the minimize go to 0% likelihood of happening? That was a strange sentence. Could you ever make it impossible to be wrong? That's a better sentence. No. That's why this class is called probability. Probability is the measure of uncertainty. There's always going to be a level of uncertainty. The problem is, can we minimize the level of uncertainty? And the answer is yes, within reason. And that's our job in this class, is to learn about that. But first things first. Speaking of uncertainty, is why are we even here link? Now, if you want to open this yourselves, I think I can click on it and open it. And if you're opening the, nope, you can't. That's okay. I got it back here. On the resource page, I'm going to click open. There's a little spreadsheet called Unbiased Estimator. If you want to open it, by all means, go ahead and open it. It's a spreadsheet. It's a little bit, there's a lot going on in this thing. I'll shrink it down so you can see. Okay, I don't know why those little green flags are in the background. I apologize. Turn them off. Turn them off on my computer, I guess. Let's do checking options. Make the color white. Make this one on my computer. Yay. Good. Lots of errors. Now you can't see them though. Kind of like my life. Okay. Now what? I say things. So, what I've done in this is I've simulated. I'm going to start and stop the video because nobody needs.